Hello guys, welcome to LeetCode, and in today's video we will discuss LeetCode question 1519 that says number of nodes in a subtree with the same label. So here we are given a tree that is connected and undirected graph that has no cycle and numbering from 0 to n minus 1. So total n nodes. Further, the root of the tree is denoted by node 0 and each tree has a label. The label is a lower case character. Further, the edges array represent the edge between two nodes, and we have to return an array of size n, that is our answer, where it represents the number of nodes in a subtree of the ith node that is same label as a node I. So let's say for this example, for this test case one, here we are given edges that represent the edge between the vertices of the given tree. Further, the labels are where each index of a label represents the label of that node, and n, that is total number of vertices or nodes, you can say. So for each node, let's say for node 0, it with label A, we have to check how many of its children have the same label as its node. So here node 2 has label A and only node 2, so we return 2 at index 0 for the node 0. Correct, 1 for the node 2 and 1 for itself. And all other nodes have characters that are not repeated, so here there comes one for each of other nodes. Let's take a look of the second example as well. Here for the node 0 with the label B, there are two other nodes with the same label on the left child and one node on the right child, so total 4 nodes, so we return 4. For this node there is only one child with the same label, so we return 2. And for these two nodes 2 and 3, we just return 1 because they have no children. So that's the similar way you can see for the example 3. So the intuition behind this question is you have to think that this tree is not a tree but a graph, because this is not a binary tree. So you can think it as a graph and make the adjacency matrix or adjacency list to solve this question. Further, what we are doing here is we are returning the answer from the child node. So for a node 0, we are returning how many of the child node has the same label as the node 0. So we are returning something. So in this case, what we can do is we would use a traversal technique, either DFS or BFS. But since we are returning answer from the child node, so DFS is a better option here, as we traverse from the parent node to till the depth of and traverse all its child. So DFS traversal is one way to solve this question. So I hope you guys are clear of the question as well as what intuition you have to use to solve this question. Now let us take a look at a few more examples so that you can build up the approach to solve this question. So here I have taken this graph where there are edges from for all the nodes. Let me build one node 0 also, because the start 0 is our starting index. Let me name it as, give it something like C. Okay. So for a node 0, there is no repeating node with the same characteristics, so we return only one here. For a node 1, there are repeating characters. Here is A, here is A, here A, and here A. So there are four same labels as for the node 1, so we return total of 5 here. For a node 2, we return 4. Node 3, we return 3. For node 4, there is no B in this subchild, so we return only 1. So similarly for other nodes. Okay, I hope you guys got the question here. Now let us take one example here. So for A, for this first node, there is no other nodes with the same label, so we return 1. For the second node, there is node with the same label B, but we can't count these 3 because this 3 is not a child of this node. They both are at same level. So we only have to check for the nodes that are present in the child. So for this 4 with a label B, with will add the answer for this node, so we return 2 here. And similarly we check for other nodes as well. So guys, as you can see here, we are not we don't have to just check for directly or the next child, but we have to check for all his children. So as you can see here, if we only check for this child, then we here for 1 we would return 2, but we have to check for all the children. So I hope you guys got it, how what we have to do. So one thing, let me note down this one point: check all children nodes label. Okay, this is the first point. And the second point is they must be children and not at same level. Two nodes must not be at same level. Okay. So here in this case, what we would do, for each node, we would return one vector of size 26. So 26 here represent all the characters from A to Z. So this would be the frequency. We would store it in the frequency. So let's say this node 6 we return this vector of size 26. Then this for this node 5, what we would do, we would create one vector v1 of size 26 and add all the frequencies of this child node of v of 26. Similarly, we would make v2 of 26. Then we would add this answer of for node 5. So that is this one. We would add it here. So similarly, we would do for all the nodes uh, present in the child. For node 0, we would add the frequency of all these nodes in this way through this vector. So every node will return one vector of size 26. And that's how we would add up the frequency of all the children nodes that are present. So guys, I hope you got the approach of how we would solve this problem. Now let's move on to the coding part where we will gain more understanding of this question. So first of all, let me make one adjacency matrix or adjacency list would be better. So I'm making one adjacency list and I'm traversing all the edges and pushing the edges in this adjacency list. Since the edges can be bidirectional, so I am adding one back edge also from 1 to 0. Afterwards, what I will do is I will create one boolean vector for visited node, and I would initialize it as false. I would also create one answer variable to store the answer. Then we will make a DFS call where we would pass this adjacency list, then labels, then answer array, visited array, and current node. So initially the current node is 0, and in the end we would return answer. So now let us code for this DFS function. So as I told you earlier that this DFS function will return a vector because each node will pass on the vector of size 26 to its parent node. Now let me take adjacency list. So since this is the list, so I kept a square bracket here. Now string array labels. So sorry, only string. Then answer vector, visited vector, and current node. So let me just name it as node. Initially what we would do, we would mark it or the node as visited. Then let's look for all the child node of the current node. And if we haven't visited the child node, then we would again call this function. But before that, let us create one vector. Let me name it as current answer of size 26 and initialize all the values as 0. So in current answer, what I would do, I would mark for the current node label as 1 because it will add to the answer. So what I would do, label of node minus a plus plus. So this will mark the current node. Then I would take another vector temp to store the answer of its child. So here I am storing the answer of the child and calling again this DFS function. And instead of node, I will pass on the child. Correct? Now I would store all the frequencies of this temp, that is the answer that I got from the child, into this current answer. Got it? So the size would be of 26. I would simply do current answer of I plus equals temp of I. here what I would do, here we have this answer vector, right? I would simply make answer of node equal to current answer of node. And I would simply return current answer for further processing. Let us now try to run this. Okay, it's showing some error base. Okay, so it is a boolean here. So bool. So here what will come instead of node, we have to pass this value as because the current answer will mark the node based on its character and not the node index, right? Okay, now all the test cases are passed. Let us now try to submit this. So yeah, our code got accepted. Further, the time complexity here is big O of n as we are traversing all the n nodes, and the space complexity is also big O of n because this recursion will be stored in a stack of the size of n. So both the time and space complexity will be big O of n. So I hope you guys understood the question, how to build intuition and what type and how we would approach this question. So that's all for this video. If you have any doubts, then do let me know in the comment section. Do like this video and subscribe to our channel. Thank you.